Hello, everybody, and welcome to another Ceph Tech Talk. I'm joined today by Yuval, who's going to be walking us through persistent bucket notifications. And as I understand, this is provides us, a additional endpoint to like our publish and subscription kind of module rather. And this is coming and the Pacific release that we're looking for coming out this month. So thank you all for taking the time to share with us this new feature, and I'll let you have the stage now. Thank you.
Thank you, Mike. Okay, so I'm going to really go really quickly through bug notifications in general. So, because this is really building on that. Bug notifications are a mechanism to let external systems know what we're doing on the Redis gateway. So whenever we put an object, we delete an object, we copy. We don't get some notification for fetching or getting an object or listing a bucket or something like that, but any modification that we do to an object, you can create a notification. This could be sent currently to HTTP and AMQP or RabbitMQ endpoints and to Kafka endpoints. And in the future, we're gonna add some more endpoints as these options. So this is something that was introduced in Nautilus and is also in Octopus, and it is working fine. But it has a couple of drawbacks. So first of all, I want to talk about the reliability of the bug notifications. The way it's done is that notifications are sent synchronously with the op. So whenever you put an object into a bucket, then after you successfully put the object into the bucket, then before we reply to the client that the object was successfully put, we also create a notification, which is like lots of metadata on whatever was done there, and send it to whatever endpoint that was configured. So if you configure your Kafka message broker as your endpoint, then notifications are going to be sent there. Whenever the broker going to act, which means say to you that now I own this message, I have my reliability and persistency and whatever mechanisms, only then we reply back to the client saying, yeah, your put object operation was successful. This gives reliability in the sense that if the RGW crashed in the middle of the process, then we're not going to send back the ACK, or the notifications was not sent, but also the client didn't get a successful completion of whatever they did, which means that they're going to retry or do whatever they want, but they would know that the notification was not sent. So it gives certain level of reliability. What it doesn't do is that it doesn't handle the case where the endpoint has issues. So let's say that a Kafka cluster is down, or maybe connectivity to the Kafka cluster is is not reliable. Then we don't have a way to solve that. We would log an error, but we can't even reply with an error to the client because we don't guarantee atomicity, because we cannot roll back whatever we did to the object. Let's say that we deleted the object and successfully deleted the object, and then we send a notification, or try to send a notification to Kafka saying the object was deleted, but this failed for some reason, then we cannot reply that the operation failed because the object was deleted. It's only the notification part of it that failed. So this is one aspect that is not well covered by the model of synchronous notifications. Another problem, and this is really something that actually happened in the field and was the trigger for adding the persistent notifications, is what if the endpoint is down or is very slow, but you don't really know about that, and the only way for you to figure out that the endpoint is down is using a timeout mechanism. So if you send something and you immediately get a reply back saying, the endpoint is down, the Kafka cluster is down, the RabbitMQ server is down, then everything is pretty much fine. But if you don't get a reply and you're kind of waiting for some certain amount of time until the timeout expires, and only then you're going to know that things didn't go, then because of this synchronicity of everything with the operation, that's going to really slow down the RTW and going to actually bring it to a complete halt. So in order to tackle those two issues, we said, okay, we need to introduce asynchronous notifications, which means that you're sending something, but you're not waiting for the reply, and you're going to reply immediately back to the client and make sure that the message would arrive to the endpoint later on. Now, just doing that is actually even possible with the existing model. You do have in the model, in the synchronous notification, you have an option to say, it's really fire and forget. I don't really care so much whether the notification is going to reach its destination, is not going to reach the destination, and I'm not going to wait for the act. So in this case, it will just work. It doesn't matter if the input is down or not. Nothing's going to slow you down. You're going to send a notification and, hope things would work. And if it doesn't work, you don't know about that. But this doesn't work as well because sometimes the reliability of notifications is really critical. So if you want to have something which is asynchronous on one hand, but also reliable on the other hand, you need a mechanism that would support that. And these are exactly persistent notifications. So this is the premise, or this is the reason for why we added this. I tried to summarize that here in the table, saying what are regular versus persistent notification, what kind of failures they're going to support, and what kind of guarantees they're going to give. And as I said, in the regular notifications, I didn't have a way to, I didn't have atomicity. So I couldn't say, okay, the operation was successful, but the notification was failed, so I'm going to roll back the operation. No, that doesn't work. And the way that I did that, I just did the notification at the end of the process. So after I knew everything was successful, but if notification failed, there was no way to roll back. So there was no atomicity between the readiness operations and the notification sending. In order to tackle that with persistent notifications, the mechanism for sending notification was what's called a two-phase commit queue, which means that you're going to first reserve something on the queue, making sure that, or almost sure that, you will be able to send a notification later on, and you do that before you start the whole process of readiness operations. And when you finish the readiness operations at the end of the process, when you're sure that everything worked fine from a readiness perspective, then you're going to commit whatever you reserved on the queue, and that's going to actually send the notification out. So these two phases gives pretty good guarantees, because if you were able to reserve something on the queue, it means you have space on the queue. And if you weren't able to reserve something on the queue, it means that something bad happens on the other side of the queue, so there are lots of problems or disconnects or things are down, so you can't really push into the queue, so you would bail out early on. Before you did any readiness operation, you would bail out and say, this operation is a failure. I cannot do the notification, so I'm not going to try to do the readiness operation, parts of it. So this is why the two-phase commit creates some kind of atomicity. It's not 100% guarantee, because the queue may be not full, so you reserve something on the queue successful, you do the readiness operations, and they're also successful. But when you try to commit, maybe you had a disconnect with all the OSDs or some other problem that are more rare, and in this case, there's no way to roll back because you already did your readiness operations. But this shouldn't happen. I mean, this is some internal problem with the with the Ceph cluster. For the cases where you have connectivity problems or some issues with the endpoint, that would be covered by this model of reservation and then committing. If you made the reservation and for some reason your readiness operation failed, then you just cancel the reservation. So you won't just take space on the queue, and other ops that want to send notifications could use this space on the queue and send their messages out. So this guarantees atomicity, but as I said, everything is asynchronous, which means that when I'm sending notification, I'm just putting stuff into a queue. Well, maybe another word about this queue. This queue is a Redis-backed object, so it also survives crashes, hardware failures, and whatever, because it's backed by the Redis object. So if the RGW crashed, or if all the RGW crashed, or your hardware really doesn't work anymore, then everything is backed in Redis object. So other RGW can come up again, or other RGWs can just send the notifications later on. So this gives really reliability in all aspects, both of the RGW aspects, and gives reliability even if your endpoint has problems. Maybe a small comment here is that even if your Redis gate, when your Redis gate crashed, there could be reservations that were taken on the queue but not committed or canceled yet. And in order for that not to accumulate and eventually fill up your queue, then there's like a periodic cleanup for reservations that are there for too long. They're just going to be deleted. So that's the mechanisms that tackle the problem of atomicity. Now, as I said, the whole process is asynchronous, which means that I'm just pushing stuff into the queue, and I need to send it over, especially for the cases where you have disconnect problem with your Kafka cluster, or you have other issues there. And for that, the only way to actually guarantee delivery, or really solve the original problem of reliability of your endpoint, is to have a retry mechanism. And the retry mechanism is based on just the fact that everything is queued, and queued in a persistent Redis object. Because some other RGW could be not necessarily the one that actually pushed stuff into the queue, is the one that reads from the queue and send messages. Now, those sends are just like the original sends, completely synchronous. So you take from the queue, you try to send, and whenever you get the ACK, you're going to clear that from the queue. If you didn't get the ACK, you don't clear that from the queue, which means that next time I'm going to go through the queue again, and whatever that was not ACKed, I'm going to resend it and retry it and so on. If I have big problems and I'm not managing to send anything, the queue would have built up and accumulated. Eventually, would fill the entire size of the queue, and then that would be signaled to the RGWs doing the operations by the fact that the queue is full. So in this case, I would just fail the operation immediately because the queue is full. I need to send notification, but I cannot, because I cannot push new notifications, because on the other hand, I cannot really send them and get ACKs for them, and therefore the problem kind of trickles back and push back to the client. But in this case, it doesn't push back to the client in a way that would slow down the client or anything. It would just immediately fail any operation that requires notifications into an endpoint or a destination or a queue which is full. The indication the queue is full is immediate, and even though I would get errors, which is what I want to get in this case, I won't get the slowdown of the RGW. So this is how this mechanism tries to tackle the problem. Now I'm going to explain a little bit about the queues and the topics and how they're managed. So in regular bucket notifications, we usually have something called a topic. A topic is really a definition of an endpoint. And so let's say a certain IP address of a Kafka cluster or a RabbitMQ cluster or a web server or anything I want to send notifications to. And then there's something called notification, which is maybe not the best name because it's not the notifications that you're sending. This is the definition or configuration of the notification. And really, this is what is tying together the bucket from one side and the topic from the other side. And together, this is a notification configuration, which means that whenever I'm getting certain events on a bucket, I want to send to this topic or to this endpoint. and this is like how all the bucket notification mechanisms work. Now, whenever I'm defining a topic, I can say that this topic is a persistent topic. It is a property of the topic itself. So I can have two topics to the same, let's say, Kafka cluster, the same endpoint. One of them would be persistent, one not persistent. The regular one, whenever I'm going to get the op, I'm going to synchronously send the notification to this Kafka cluster. The persistent one behaves a little differently. So when I'm creating the topic and I'm marking that as persistent, the first thing I'm doing, I'm creating the queue. So I'm creating a queue, and this is the Redis object or the queue, the two-phase commit queue that later on I'm going to use in order to send notifications to this endpoint via persistent topic. Now, it is important to understand that you're going to have a queue per topic, and this is critical for the case where, let's say, you have multiple endpoints. Some of them can be good, some of them can be bad, some of them can be down, some of them can be slow, and you don't want the slow one or the bad ones to impact the other ones. So it could be that one of your Kafka entry points or brokers is down, but the other one is good. So only this specific queue is going to build up and fill up and eventually fail, but the other one is going to keep on sending. So there is some separation and isolation there. So I'm creating this this topic and as a result this queue. And what's going to happen is whenever I'm going to have an operation on a bucket that has a notification configuration that ties to this queue, then I'm going to push the notification to the queue. And the RGW is getting the operation. This is the only thing they're going to do. Just push stuff into the queue. Now I need somebody to pop stuff from the queue and send it over. Now, anyone can push stuff into the queue. There's no requirements on guarantees or any sorts. But the person that is popping from the queue and sending to the endpoint has to be only one. And this is to try to prevent reordering. Now, reordering is not guaranteed to be prevented because of retries. You can always have reordering, and whatever system that sits on the other side has to be able to handle duplications and reordering and everything. But they have to be able to handle them only when problems happen. They shouldn't be needed or required to handle duplications and reordering on a regular basis. This is why we want to guarantee that in a regular operation of the system, there's no reordering and duplication. So for that purpose, you need a single RGW at a certain point in time that pulls stuff from the queue and send it over. So we're using object locks for that. So whenever a new topic is created, arbitrarily one of the Redis gateways is going to see that, because there's a list of topics in the object, see that and try to take ownership of this topic. It will do that using a CLS lock, and if it is successful, then it became the owner of this topic and will kind of own the queue, start to read from the queue and send to the endpoint. If it failed to take the lock, it means that somebody else owns this queue, which is good because somebody else handles that. Now the queue or the lock over the queue has to be renewed, and this is for the case where RGWs go down. So if one of the RGWs owned a couple of queues and served them, which means it emptied them and sent it over, this RGW can crash and go down. And then we need to make sure that after a while the lock would expire, so some other RGW would try to log and be successful all of a sudden because the lock that the crashed RGW expired, and then the new RGW would be the new owner of the queue and would start to empty it and send messages over. So this is where how the mechanism works. So once you own the queue, you renew your lock, periodically, and if you don't renew that, it means that you're down and somebody else can take the lock and start serving this queue. This is how we guarantee that there will be no reordering or duplications on a regular basis. And on the other hand, there will always be an RGW that manages a queue and serves it. When you delete a topic because you don't need this topic anymore, or you decommission the Kafka cluster and you want to take down the topic, it also deletes the queue, and there'll be no new notifications being set for this one. What else? So yeah, I mean, in this gist, there are a couple of commands that can help you figure out which RGW owns which queue. This could be helpful uh, for the purpose of debugging like a large system that has lots of RGWs and so on. Um, the kind of gotcha that exists there is that currently the identification of the RGW that is owning the queue. So and this is part of the Redis command figure out the queue is based on the Redis client ID or this address identifier, and you don't have a good way to get those except looking at the log file, at the RGW log file. So we probably need to improve on that, but for now, the only way to kind of associate a certain queue with which is the RGW that serves it and empty it and send the notifications from it is by running this command and then matching that to whatever you see in the RGW log. Um, so this is pretty much what I wanted to talk about when it comes to persistent notifications. Um, Mainly, give some hints about debugging and how the mechanism work if somebody is using them and things are not working or not working as they expect them to work. Um, so I'll be happy to answer questions, or if you want me to explain about other things.
Sure. I have a quick question, Yuval. So,
Yeah.
Yuval, in the end, you had mentioned about the two lock-in timer periods. One was
Mhm.
90 seconds and one was 30 seconds.
Right.
Is that configurable or is it hard-coded?
I think it's hard coded. I mean, it's pretty easy to add that to configuration, but I think it's currently hard coded. So 30 seconds is the time where I renew. So if I own a queue, that I'm going to renew my ownership every 30 seconds. And 90 seconds, this is a timeout for the lock to expire, which means that if I'm down, then at most 90 seconds after I'm down, another RGW is going to pick up on this queue and start to own it and serve it. Um, so what would be the concern? Like, why would we need to change that? I mean, could be good reasons. I'm just asking.
So I was just thinking if a user has, only two RGWs in their cluster and both of them have, can both these RGWs acquire lock on the same object? Apparently not, right?
No, no. I even try to kind of prevent all kind of potential. So the the lock is a CLS action, which means this is something running inside the OSD. So on a certain object, there's only one OSD that can do any operation. This is completely atomic. Um, so if somebody is trying to take a lock on a certain object on a certain OSD, only this code can run there. No other code can run there at the same time on this OSD for this object. So this is why the locking mechanism is guaranteed to work. I also create a little bit of jitter in those timeouts to make sure that there's not too much race conditions at the same time. Exactly, like if the both RGW started at the same time, I don't want them to the cycles to be completely in sync. So I'm edit some. So it's not exactly 90 seconds. I added some jitter there so to make sure that it doesn't really match. Um,
Okay, but if one RGW goes down which had that lock, the second one will have to wait for 90 seconds, right?
yes,
Before it can.
yes.
So if a user has that problem, so if and they want to customize that and probably tweak it down to let's say 45 seconds,
Right.
probably
So
would it be a
so
use
this
case to yeah.
could be, yeah, it could be. I mean, depending with the rates, and especially if they're like only 200 Ws, this could be a valid concern to because I mean, what can happen is that if the rates are really high, then during those 90 seconds, the queue can fill up, and then all of a sudden you would start to get errors, and it's like and you just waited for 90 seconds for no good reason because you could have picked up on this queue in 10 seconds, maybe. So, like, I don't want, like, the reason I took those numbers because I don't want, like, false positives. I don't want because, one RGW is really busy with doing something for a couple of seconds and didn't have the chance to renew, then I don't want it to lose the ownership for no good reason. But 90 seconds could be decreased. I think, I mean, you can submit an RF3 in the tracker for making this timeout configurable or even making the hard-coded numbers smaller.
Sure. I think making it configurable would make sense depending on the use case and the number of RGWs they have. I will add a tracker.
Yeah, that'd be great.
So maybe you could speak on like future development in terms of this feature. You mentioned currently right now to see the queue's ownership, you have it pulled up right now in terms of running this particular command. What is the plan, if any, for Quincy?
Yeah. So I'd be happy to talk about like some future stuff with the back notification. So first of all, yes, I mean having to debug that myself kind of really proved to me that the we need a little bit of tooling here. Trying to match something by scanning a log file really doesn't work so well. So having a command that really tells you which one owes what is going to be great, and that's going to be surely added. We're also thinking, or not thinking, this is actually kind of almost done and in ready state, that we're going to add more endpoint types. So as part of the 2020 GSOC project that we were part of, there was a student that added AWS endpoints. So the student added a Lambda endpoint and an SNS endpoint. So SNS is like Kafka, only it's an AWS service. And the Lambda, this is like the serverless function of AWS. So you can, instead of sending notification to Kafka or to RabbitMQ, like in an on-premises case, you can send notification to an AWS SNS that would do whatever they want with it, or you can even trigger an AWS Lambda with it. So this is almost ready, hopefully pretty soon. So that's another, and we're also talking about some other options. I mean, we might be adding. So we're supporting AMQP, the RabbitMQ version of AMQP, which is the more common one. But there's also an AMQP 1.0 version that is supported by ActiveMQ. So both the Apache project and Red Hat products support that. And we're going to add this as another endpoint there. So these are a couple directions that we have there. I mean, there are always fixes and enhancements to our to the implementation of communication with Kafka and other things. But overall, this is where it's currently headed. Another thing that is kind of on a back burner, but might also be in Quincy, is to send. So as I said, back notification will send when an object is put or deleted or copied and so on. We also want to send notification when an object is deleted due to a lifecycle policy. So this is currently not supported, but this would be a very nice enhancement in the sense that, if somebody is interested in deletion of objects, lifecycle deletion is also deletion of objects. So this is another use case, and this is also going to be added, hopefully in the near future, to as a notification trigger. I think that's it. I don't have any, but I mean, this feature is really picking up in the past year or so. And the more it picks up, the more feedback we're going to get. We're going to add more features and make the users of this feature as happy as we can. So there'll be other enhancements for sure.
Yeah, and thanks for mentioning the Google Summer of Code. I did put a link into chat in case people want to take a look at that. I noticed as well that you have, those two projects, the next level advanced message queue protocol project as well as going Nats. So it's pretty fun. Um, and
Yeah, yeah.
yeah, go ahead.
Sorry, just one more. So the going Nats is an example of how maybe we wanted to add notifications for endpoints that are not that important. I mean, like one-offs. So the idea there is that you have your like Nats. It's like a Kafka that it's a cloud native like a CNCF project, whatever. It's not very commonly used, so I won't go and put that in our code base. But maybe somebody really wants to send notification to it. So we want to enable that via like a scripting mechanism that is more kind of ad hoc integration point than writing C++ code, putting that in our code base, and so on. So that's been an example for something like that.
And apologize for my ignorance with this feature in particular, but is this something that might get surfaced up to be configurable, like in the Ceph dashboard as an operator to a Ceph cluster?
So there is work to add bucket notifications to Rook. It should be. I'm not 100% sure where it stands right now. I was involved in the design process, and we're going to add that to the CRD. So whenever you define a bucket, you can also define. I mean, you'll be able to define topics and then tie the topics to the buckets via notifications, and that will be part of Rook. So yes, currently sometimes defining bucket notification could be a little bit cumbersome. I mean, you have to run a couple of commands. Although you can use the standard tooling for that. So the AWS CLI tool and Bodo3, both they support the topics and everything. So it's not like you have to craft your own REST client for that. You can use standard tool, but still, writing a YAML and pushing that into an OpenShift or Kubernetes cluster is easier. So the design for adding that into the bucket or bucket claim. I mean, there are a couple of things there. CRD was done, and hopefully this will be implemented. I'm not sure when, so I'm not really in the loop for the implementation there.
So for the operators that are tuning in, what exactly for enabling this in Pacific, what steps do they have to take? You did mention some CRDs inside of Rook, but I don't know if that's actually necessary.
I mean, if this is just running a Ceph cluster, then everything is supported via standard interfaces. So you can use the AWS CLI. You can't really use the S3 CMD because the topic and stuff, those are not S3 commands. Those are SNS commands. Those are standard AWS tool set commands, but they're not S3 commands. So you need the AWS CLI or Bodo3. Both, it's the same thing pretty much. We support, we work with them both. I'm going to put the link. I have.
We had somebody who linked the actual docs. Would people be able to find that in the latest docs?
Well, in the docs, we're kind of more generic. We're not talking about specific toolings, but here we have explanations about how to actually do that specifically for Bodo3 and AWS CLI. So even we extended and changed the interface a little bit, like we have more than the standard AWS support, but we also provide a file, like it's a JSON file, which is an extension. And if you put this file in place, then you're gonna automatically get all of our extensions through the standard tool. You don't need to change one line of code in Python or in the tool. And using this file, you can actually get all of our extensions and modifications to the interface. So it shouldn't be too bad. I mean, if you don't need to craft your own messages or curl-based client or whatever, you just use this AWS tool, or border 3 if you use Python, and things should be just working. So it shouldn't be too bad.
Well, so if people wanted to get involved and join you for future development in Quincy,
Mhm.
how may they get in contact with you? I'm assuming on IRC and the Ceph mailing list, but
Yeah, I can paste my email. On RSC, my handle is this,
okay.
and
And I'll put these
and
all in the video later so people can
sure.
just find them on there.
And I mean, you can also put my Red Hat email. That is also a great
I
way
could
to
take care of
contact.
that. Yep,
Okay, awesome.
no problem.
Okay,
All right. All right. Well, great. Thank you so much for taking the time. I understand, you're taking, especially after hours now, you're in your own evening. So I hope you do enjoy the rest of your evening and have a relaxing time. And I thank everybody as well for joining us and tuning in for this neat feature inside of Pacific. And I would also like to remind people that we have our Ceph user survey that is ending April 2nd. So please fill it out. I think that would also help us in certain initiatives like this, as well as understanding how people are using Ceph. So, all right. Until the next Ceph Tech Talk for next month, thank you everybody for joining us. And that ends everything. So.
thanks, Mike. It was a pleasure being here.